Consulting, and he's an expert in ISO 21434, UNR 855, and ASPICE. So thanks for being here, and looking forward to your talk.
Thanks a lot. I don't know, does this work now, or?
This is just for the recording.
Okay, all right. Thanks a lot for having me again. I've been here last year as well and had a rather different talk, I would say, because I was, I think, the only one who was not directly involved in testing. And also, I'm one of the very few people that are not fluent in Python at all. In the meantime, some stuff has changed. I am working for CYEQT. I'm your sponsor today. In the meantime, I also have a lecture at the University of Applied Sciences in Graz about automotive cybersecurity engineering. And what's more recent, I also switched, at least part-time, back to the dark side. I'm also now helping out in breachlabz, so I am testing a bit as well now. Before we get into the primary topic of SecOC, a short flashback to last year, where I presented some of the stuff that we kind of still see in automotive security, even though it shouldn't exist anymore. For example, 16-bit seats and so on. There is things that have been evolving in the last year and also before that, and some of the things that really changed or are changing I want to highlight because it might have a direct impact on your work as well. There's different things that I see happening or have seen happening in the last few months, and it might or might not make your life more difficult. IDS, intrusion detection, is really becoming a thing. I would say that in passenger cars that are developed right now and will enter the market, there was a concept before called security event logging, where an ECU would log certain things that happened, like you try to unlock security access and you gave a wrong key. It would record an event. And there was a good chance that you could read that out or even manipulate that. With intrusion detection, it's kind of the same. But now they don't record it anymore, they forward it to a central gateway, which makes it more difficult to tamper with it after the fact. And if you get intrusion detection data, lots of it, I would be very interested in it too. I'm not the only one, I think. By the way, unfortunately, the data within the vehicle is standardized by AUTOSAR, but the data that goes out of the car is not standardized. And I don't think that's a good idea, but that's a different discussion. What we also see a lot, some movement in passenger cars, is the move from security access to authentication, which I think is a brilliant idea, also because you can then give out certificates that are flexible. You can change access rights. You can you could even give like aftermarket people a certificate that is valid for a certain time, for the runtime of your contract, for example. This also makes it much harder for attackers, in my opinion, to directly get access to, for example, your own car or your neighbors. But there is new attack vectors, of course, for example, certificates. Actually, they also are cleaned up with the 16-bit seats, unfortunately. So also the owning the key, you really need the key if they didn't screw up the implementation. Automotive Ethernet is coming. And since we are talking about SecOC today in more detail, there's two siblings, I would say, that are connected with automotive Ethernet, IPsec and MACsec. And those are very similar to SecOC. SecOC will probably lose relevance over time when Ethernet, some IP and so on are introduced and are kind of replacing parts of the CAN protocol that is spoken in a car. But the concept is still relevant because everyone kind of does it the same way with IPsec and MACsec. So whatever they do, which I will talk about in a minute, is still relevant in Ethernet. I didn't believe it when I saw it, but post-quantum cryptography is now being implemented in cars. For the first time, I saw a specification about 3 months ago, that mentioned a software signature, not only doing an Edwards curve signature, but also a Sphinx Plus signature. So this is coming. Whether it's good news or not, I mean, it's hard to these days to break an asymmetric curve key. I wouldn't expect anyone to be able to do that anyway, but let's say in 5 years, if you get your hands on a quantum computer, bad luck. So mainly software signatures, but I expect the same thing for certificates relatively soon. And there is this rather interesting topic, in my opinion, for you especially. They will implement updatable HSMs and crypto agility. So the same specification has these 2 topics in it, which is kind of surprising to me, because a major OEM's cybersecurity engineering head told me or asked me in a completely different discussion, have you ever seen a secure flash loader? And my answer was no. So I really wonder whether this is a good idea or not. If it's not a good idea, it's good news for you. All right, but let's go to SecOC. It's one of my favorite topics because in my lecture, this is the point where every cryptographic concept was introduced. You need everything for it. You need key distribution, you need symmetric ciphers, you might need hashes, you very often need hashes, and you need asymmetric cryptography to explain the whole concept. So this is kind of where it all fits together for the students. The fun part is there is a definition how SecOC should be done in AUTOSAR. And it's a pretty straightforward concept. We have seen it today already. You have 2 measures actually that prevent an attacker to spoof or tamper with messages. One is a message authentication code. Cryptography applied to the message that applies a secret to it. So the most common format is a CMAC based on AES, and that protects the whole content of the message. Now you could still replay it. You just record some traffic and replay it, and to prevent that, there is what's called a freshness value. So you cannot easily replay a message that has been sent before, because the receiver will then see, okay, this is from the past and I've seen it before. It's probably a replay attack. By the way, protocol data unit doesn't mean CAN message. Could be applied to any protocol. And also, PDU ID doesn't mean CAN ID. It's very important to understand because a CAN ID can change between CAN segments. The PDU typically does not. It stays the same. Otherwise, the gateway would have to, apply. It would need to understand the MAC and check it, and then apply a new MAC, and so on. So that is not done. PDU IDs are stable over the whole network typically. What's also quite interesting, in my opinion, is everyone truncates the MAC and the freshness value. It's also subscribed that way in AUTOSAR. And pretty much everyone does it exactly the same way, especially exactly like AUTOSAR defines it, which is kind of interesting. Also, what's kind of interesting is almost everyone, not everyone, but almost everyone applies a CMAC 128 bits exactly like AUTOSAR defines it. So the MAC is kind of handled pretty uniformly. Just to add the receiver side, so first you check whether you're actually dealing with a fresh message, not a replay. Check the message authentication code of the whole message, and then determine whether it's fine to process or not. Now there's 2 things that, there's one thing that AUTOSAR doesn't define, and there's another thing that AUTOSAR does define, but everyone is doing it differently anyway. One is key distribution. Key distribution is not defined in AUTOSAR. And the fun part is, at least the specifications I know deal with the key distribution for SecOC the same way as the key distribution for MACsec and IPsec. And there's 2 general approaches for it. This is the approach I don't like. It's what I sometimes call the American way. But it is actually also applied in Asia very often. The OEM in that case creates key material, sends it over to the supplier, and the supplier puts it onto the ECUs. And typically they call it non-group keys. Non-group because every ECU and every produced part, so every serial number, gets a different set of keys. There's encryption keys in it, symmetric. There's some signing keys in it, and so on. But the important one is the encryption key. It's symmetric, which means every produced part has a symmetric key on it, which is attached to its serial number. And somewhere in the back end, the same symmetric key is stored alongside that serial number. A huge logistic effort, as you can imagine. If you can't imagine, the thing is, if the internet breaks between OEM and supplier, the supplier can't produce anymore unless he has a reserve of key material for the ECUs to be produced in the future. And then, let's say he needs to scrap a part, then he needs to somehow report back which key packages he used for which ECU and which ones he had to throw away. So it's really a logistic nightmare. There is another thing that is not good about it. Whenever you want to replace an ECU in this scenario, you need to connect to the backend, because only the backend knows how to give the group keys, which are the keys for SecOC, the session keys you could also say, to give that back to the ECU, to the new one that is put into the car as a replacement. Second approach. And by the way, group keys and non-group keys, what they usually do is they put together a group of ECUs that kind of share the same session key. Also kind of not that great of an idea. The other approach is to put a session key to each PDU. So to each, for example, different CAN message. Much better idea. This is the approach most European companies use. They build everything on a trust model between ECUs. So all you need to put on an ECU as a supplier is a certificate. That's it. So the OEM is involved because he signs the certificates. But every ECU gets an identity, like a passport, a certificate, that the signing request is generated by the ECU itself in the HSM. And during production, the signing request goes to the OEM, and later the OEM puts the certificate onto the ECU. So yeah, you still have this certificate needs to go to a certain serial number, but at least you are protected against outage of internet. You can produce, you just put the signing request onto the ECUs, you can keep producing. Later, the OEM puts the signing request, the signed ones, the certificates onto the ECU. Much easier. So how do you distribute the key now? The easy way is, once the car is assembled, there is a central ECU that you trigger, and it will then produce a secret, a random secret, and using the trust model of the ECUs, spread it to everyone. And then each ECU goes ahead, applies some hash over the PDU ID and the secret that was just spread to get to the session keys. So every PDU gets a different session key based on the vehicle secret. You replace an ECU, you just spread a new secret. That's it. You can do that offline, because the ECUs trust each other. That's the beauty of this approach. It can be done offline. And by the way, there is a new development where the central, what's often called the security master, does not spread the secret, but rather calculates for everyone the PDU ID keys and spreads those to the ECU that it needs. So that a rogue ECU cannot just, by having a certificate, kind of calculate all the PDU session keys. It would only get the ones that it really needs. But this is the approach that is mostly done here. There's one scheme that I find rather funky. I don't want to show the picture. Can you imagine a Diffie-Hellman scheme, but with multiple ECUs involved? If you can't, look up Burmester Desmet. It's a multi-participant key exchange based on public key infrastructure. And yes, it's applied. You don't want to implement that, I think. But it's done. And in that case, it's done per, they also have groups of ECUs talking to each other. And those groups then also like determine session keys based on this scheme. It's easy to find pictures of this. And if you see the picture, you know that you don't want to implement it. All right. So now the only thing left is how do we protect the traffic from being replayed? And the normal answer would be, yeah, just have a counter, right? Have a counter, count up, calculate the MAC over that counter as well, and you're done, right? But funnily enough, that's not really what is done. And I don't really understand why. It could work, you know, just have a counter and that's it. But instead, there's AUTOSAR profiles, and one of them is a counter, and it could be done, but no one does it. What is actually really used is the profile 3 with 3 counters, and yes, I have seen at least 3 OEMs doing exactly the textbook application of what's written in AUTOSAR. One is a very small one, but the others are rather big. There's other companies that have like a global, you could call it a clock. They have global time, they use a tick counter to have global time, and they use that. So if there's a message from the past, the tick count would just be very old. And everyone can judge whether a message is fresh or not. What also is, can be done in both approaches, you don't send all the counter or freshness value. You just send parts of it. That's actually applied almost always. You don't always send the whole counter. In fact, you could actually not send a counter at all. That could also work. No one does that, unfortunately. I'm quite surprised to see this kind of a specification, and then 2/3 of the market ignore it, because AUTOSAR is supposed to be a standard. But let's talk about this profile. So it has 3 counters. There is the counter that goes up with every message. So whenever a message is sent out, the counter goes up. And then there is what's called a reset counter. And what it is every 2 seconds, 5 seconds, depends on the OEM, they reset the message counter and count the reset counter up 1. It's kind of interesting and might be exploitable. And then there is, and by the way, there's a message that resets the message counter and counts the reset counter 1 up. And then there is the trip counter, which actually when you turn on the ignition is counted up and it resets both of the others. It's also kind of interesting. Any idea what might be exploitable already? Let's see. What almost everyone does is they only send parts of it. And very often they only send parts of the message counter, sometimes the whole reset counter, not always, and sometimes the trip counter, all of it, not always. Sometimes they shorten this to just 2 bits. Kind of interesting, no idea why. It's all just not sending all of it, I guess, but hard to see why this combination. I didn't find a reason. If anyone knows a reason, a valuable or like a reasonable reason, I would be glad. I didn't see any yet. Can you see anything that, let me show you this. This is how the counters evolve over time. And there's one particular point in time that is quite interesting. So, message counter, lower and upper, reset counter, and trip counter. And there's one particular point in time, ignition, where 2 are 0 and 1 is at a certain value. I would say that's pretty predictable because the number of trips a car does is not very high. How many trips do you think a car does in 10 years? 3,000, 5,000? That's probably it. You could probably brute force this pretty easily, right? So I don't know what they thought when they invented this scheme. Is that clear to everyone, I hope, that this can be guessed pretty much? All right, here's another approach. And tell me what you think about this one. You have global tick count, like a local time, and that's the freshness value. And it's attached to every message. And what you do when you receive a message is you take your time and the time of the message, and then there is some tolerance, plus and minus, and you take whatever is closest to your time and use that for MAC calculation and see whether you have a success or not. Is that a good idea? The thing is with this one, there is a tick counter that is synchronized every now and then, which again makes it very easy to guess what the actual tick count is because it's actually broadcast. So, by the way, the only reason I could see why the freshness is as complicated as this is, if you assume that someone guesses the MAC key, then this makes some sense. Not much, but you know, it's another level of, okay, you can still not spoof messages because you also have to get the counter right. In this case, yeah. But as I said, you can probably guess it. In this case, no hurdle at all, I would say. Just wait for the next sync. There's your counter. Now the scheme I like most. Pretty complicated, but at least to some degree effective. It's also from a European OEM. They have a pretty nice trick up the sleeves. What they basically do is they also don't send you the whole counter. They send you parts of the counter. I think it's 24 bits they send, but they have another, it's not many, it's 16 bits I think, that they don't send. They call them rollover protection bits. All right? And they start the rollover protection bits at a random value that is spread in the car, of course. Everyone needs to be on the same counter. What the receiver now does is, which is kind of interesting, it doesn't take the counter and compares it directly with its own counter to see is this from the past or not. It does that, but it doesn't come to a conclusion directly. The logic is, if the transmitted is bigger than my own counter, we are fine. We use it. We use the transmitted counter and go from there. If it's not, then I take the transmitted counter temporarily and increase my rollover bits. I assume that there has been a rollover. And then with the counter from the message and my rollover protection bits, I try to get to the correct MAC. If it doesn't work, I go back and increment one more time my rollover bits. Try to see if I get to the right MAC. If it doesn't work, I try one more time. There is a threshold of attempts I am allowed to take, and if I can't get to the correct MAC, so the only thing I compare is the MAC. If I can't get to the right MAC by counting up my rollover bits, then I say, okay, this is probably a replay or some spoof message, I'm done. Any thoughts about this? I like it as a double network against someone who maybe got to the session keys. If you make this one long enough, what you have in effect is a second key that is purely random. So it's kind of a double net, very much like secure boot is for secure software updates. So it's kind of a second thing you have to guess, otherwise you can't get a message correct. All right, so this is actually a pretty nice idea in my opinion. Again, it's extremely complicated and I'm not sure it's worth the effort because a simple counter protects against replay attacks already. So again, not sure it's worth the effort. But it's effective. If you make that rollover protection bits long enough, you in effect have a second key to guess for the attacker. All right. Conclusions. The AutoSAR Profile 3 is complete overkill in my opinion. It introduces a lot of complexity and it's easy to guess in the end. Once you know, two counters are 0, the last one is the trip counter, which you can probably brute force easily. You know, one message is enough, right? Under the assumption you have the session key, you just need one message and you can just try out the trip counter values that make sense and get to the right MAC and that's it. Then you know the counter. So I don't think it's really worth the effort. By the way, fun story. One of the companies that implements this, they assembled all of the security experts and implementers of the different suppliers on their site, on a board that had all the ECUs laid out because they couldn't get it to work, partly due to the freshness value. So they actually sent everyone the freshness value component. So in theory, everyone should have had the same implementation, but somehow it didn't work. So I guess some people did not have the same implementation for some reason. But this is a nightmare to configure really. And worst case, you spend a lot of effort trying to synchronize the implementations. I think they changed some of the what if a message has a counter that is 1 too low. They kind of accepted that, then decided, no, in the future we don't accept that anymore. Maybe someone still had the old implementation. I don't know what happened, but they needed to fly in everyone to figure this out. So no, it's not a good idea because it doesn't really do much over just having a regular counter. Global tick counter. If you just rely on it for replay protection, fine. You know, that's a good approach if you don't really rely on any, like a second level of security in case someone guesses the session keys. Do it, not much of an effort, except for the synchronization. By the way, nice trick. The sync message is a bit faster than the internal tick counters. That makes sure that when you receive a new tick count, it's always ahead of your own time. So they kind of apply this factor of 0.95 or something, where your time is slower than the sync time, which makes sure that you are always up to speed. This is, I think, a good idea. If you implement a scheme that is a bit more involved than just having a counter, then obscure it at least. Then you have a second key. The only question then is, how long do you make it? I would rather make it quite long. Then it gives you a chance, even if someone gets their hands on key distribution, for example, then you still have a chance to not being attacked by this attacker. And by the way, key distribution algorithms are quite broken very often. So if you kind of figure out what can be done, reset to default keys per routine control is one, then you have the counters, the MAC keys. So having a double net might make sense. All right. Any questions about SecOC before I jump back to where I started? What I said earlier is the developments in automotive engineering that I've seen make some stuff a bit harder for you in the future. The one word that is important on this slide is passenger vehicles. So, as I said last year, I believe, because I kind of say it every chance I get, what could you target still? if you need a challenge really, then yeah, I mean, by all means, it's the exciting stuff, right? Extract key material, spoof certificates, at least try it. Exploit vulnerabilities. Of course, that's where the fun is. So yeah, grab what you have, chip whisperer, all kinds of equipment you can grab, because also that's where the fun is, right? Actually, if you want to have some real impressive results, but have a relaxed hacking life, then you just target commercial vehicles. Sorry about that, but commercial vehicles have some serious challenge to resolve. First, they have to do some homework still. So lots of commercial vehicles we see either in testing or in engineering, so it's still stuff that is developed right now, hits the streets in, I don't know, 2 years. There are still instances with no SecOC. And by the way, SecOC is a very tough topic to tackle for truck and trailer, because truck and trailer are two different companies. You don't even know what trailer companies are in the market in 5 years. And also the logistic companies mix up truck and trailer like every day. So how do you spread a secret between the two? Difficult. It's not that difficult, but you need a lot of coordination effort to make this happen. No UDS 29 nor 27 also happens quite a lot. So you have seen that's a very funky implementation, I would say. We have seen the opposite. Very modern network, J1939, no security access whatsoever. And then the guys say, yeah, but if an attacker can approach the truck and connect his device to the truck, it's standing, right? So yeah, just let him perform diagnostics. I'm like, are you kidding me? So they don't fully grasp the dimension of diagnostics, I guess. And also sometimes no software signatures. You can just apply software updates, no problem. So owning the system, very often possible. And then go to the trailer and so on and so on. So yeah, if you want to have quick results, and I would be glad to see some more stuff happening, to be honest, because then we have a point in our work. All right, that's it. Any questions are welcome.
Thank you very much. Yes, please, here we go.
Thank you for your presentation. I actually have 2 questions. The first one, on the key distribution, you mentioned that the ECUs then have to trust each other. Can you elaborate a bit more on this, and especially how they do that if a part was just replaced?
So there's a full trust model in those ECUs. Typically, it's pretty involved. So the certificate chain has 3, sometimes 4 levels. One certificate is for the ECU. Typically, there's one that covers something like this model, for example. There's a certificate that is given out by the OEM that signs every ECU certificate for that car model, let's say. That is signed by most likely a certificate that covers the whole fleet of the OEM at a certain point in time. And that is all online. So in theory, you could check those online as well. And the ECU has the public keys for the whole chain. And then sometimes there's a root certificate on top that is offline, used to replace the certificate chain in case there's a leak. And then, the ECUs can, when an ECU presents you as the other ECU a certificate, you can check the signature of the CA because you have the public key, and you can trust that it has been signed by an OEM instance for the current model, for example, or the current fleet. No.
So if you were to extract one of these certificates from an ECU, you can present yourself as this.
You still, if you can extract the private key to it as well, then yes.
And this is in the ECU?
This is in the HSM. So typically, if they apply this kind of a trust model, they also require you to have an HSM. So the ECU generates a key pair in the HSM. There is some diagnostic service to retrieve the signing request, goes to the OEM. Later, the OEM puts it back to the ECU. Yeah. So it's what I would say is a common practice in IT anyway. Yeah.
Thank you. That answers my first question. The second one about the hidden rollover. Wouldn't that just increase the likelihood of brute forcing a valid MAC?
Would it increase the likelihood of brute forcing? The question is, so I don't think so. What about a counter? Just a regular counter that counts up from 1?
Because you basically try validating the MAC with different counters.
But you still need the MAC key, no?
Well, but if you don't know the MAC key and just send random MACs, like now there's technically multiple MACs that could be.
That's when you truncate the MAC, that's true anyway, right?
Yes.
Yeah. So truncation, I don't think so. It can be debated whether truncation is an issue anyway for the MAC. Typically, I think they truncate from something like 16 bytes down to 8. That's the common thing to do, I would say. And yeah, 64 bits you could, in theory, brute force for one message. Still, you don't get back to the key, I would say. And the counter, I don't know how you would do that, brute force a MAC based on that. You could, in theory, of course, do what the receiver does. If you have the keys, let's say you have the keys, you could count up, yeah, and then the question is how long is that hidden part, right? If you make that 128 bits, let's say, then it gets tough to brute force.
Okay, thanks. Another questions? Over here.
Yes, hello. Thank you for your presentation. I have a following question. I'm coming from Riemann industry, so you have experience talking directly to OEM. So my question is, European Union force us to implement the goals of the green economy and circular economy. So every garage now is forced to install remanufacture parts in vehicles, even the car is on the warranty. So looking at what you explain us very nice about the keys, for example, and the SecOC. What do you think? Does it mean that the European Union is just neglecting their own future plans, or how it can be implemented or solve the problem?
You mean to become greener, like from a power consumption?
So does it mean that we have now asked governments and force them to add a special rules, or I don't know, for the remanufacture, or because I don't see like now, okay, we're working on the 5 years old parts, not a problem. Or even like you said, even still something is produced which is not very sophisticated. But what we talking about are the plans for next 2 years. So what should we create some government initiative to say, look, what you're asking us, it's not be able, or we can't do it, fulfill your plans in 2 years.
There is one problem with SecOC, in my opinion, and it affects many people, which is you are at the mercy of the OEM. About 2.5 years ago or 3 years ago, I asked a guy that was in the regulation scene, and I asked him about a case I had in a project where an OEM takes vans from a big OEM and retrofits an electric powertrain into them. Those guys are in trouble very soon, because when the big OEM introduces SecOC to those commercial vehicles, so it's kind of happening at some point, but I don't know when, but it will happen. And then the problem is they need to talk to the original ECUs that are still in that van, like ESP and so on, but they can't, because they don't have the keys, right? Unless the OEM lets them in. Unfortunately for the big OEM, the original OEM, that's not a very attractive market. It's a niche market, and so I don't know what will happen. The same issue for replacement workshops, right? It's very tough to replace parts without the cooperation of the OEM, which I think is a major problem, right to repair and so on. Third problem, what about manufacturers that take cars and for special purposes, like ambulances, right? They need to, for example, be able to overcome the speed limit that might be attached to that original car. Also, that is a niche market in fact. So they are, the original OEM is not interested in opening their doors at all. I've been in that discussion, and it's going to be a tough one. And I would say, yeah, the OEMs need to open their doors for aftermarket changes. Whether they will or whether they will be forced to or need to be forced to remains to be seen. I would be on the fight for making them open their doors, for sure.
Thanks. Is there another question? Is there one?
Thank you for the very interesting talk. I have one question about the obfuscated counter. What I didn't understand is this overflow part, when is that transmitted? Is that transmitted with the synchronization, or is that done during assembly at some point?
Assembly, okay. Yeah. A random starting point, so to say, and then just rolling over. Yeah.
Okay. Other question?
Thank you for the interesting talk. Maybe it's a bit somehow related to the question that has been previously asked, and you mentioned the example of retrofit. As far as I know, retrofit are not subject to the UNR 155, right?
They are. It depends on what exactly you do, and also what kind of fleet size you have. But in general, for example, if you replace a combustion powertrain with an electric one and then have that's a rather drastic change, they are subject to UNR 155. Yeah.
Oh, okay.
Yeah.
So in that case, in case it's not subjected, it can just say, I do not want SecOC because it's only at regulation, I would say.
Of course you can do that, but the problem you have is not the regulation. The problem you have is you have the original car, it does have certain ECUs, and you can read their messages, no problem, right? If the ESP sends you the speed, for example, you can still say, okay, I don't care what the MAC is, I just take the message and read it, but you can't write to it. You cannot send out messages in the name of the engine ECU, for example, to make the car believe, oh, we are in 4th gear and the RPM is 4,000. Because in reality, the RPM is something else and there is no gears. And the ESP won't believe you because you can't attach the right MAC, and then the ESP doesn't work anymore. That's the problem. So the car doesn't work anymore.
Thank you.
Thank you. One more question somewhere? Okay. Then, thanks again for a great talk.
Thanks.
Thanks for having me here.